Hey guys, so today I've got an exciting video for you. I'm going to talk about QUBIC's white paper, which was released about a week ago. It's about 80 pages long, so it's a big read. So I wanted to read through it first, gather my thoughts, and then give you this review. So we're going to look at the white paper. So let's get into it now. So guys, to begin with, let me just say that what kind of my general thoughts on the white paper. So my general thoughts are that I read it, and in a way I was kind of underwhelmed because I've studied QUBIC so much, and probably if you're following this channel, you guys have studied it a lot, and most of the stuff in the white paper isn't particularly surprising. So, covers most of what we know. So it's kind of for people like us, it's what we expected. There's some other small issues that I have with it that I'll cover as we go on, but it doesn't jump into depth on some topics as much as I would like. It just kind of just gives you kind of an overview of what it is. It doesn't explain how certain things work. I'll explain that as we get through. But all in all, it's a really good white paper. There's a lot of work went into this. It's just when you compare it to a white paper like Cass's, for example, that's super scientific. QUBIC's maybe doesn't have the same level of depth. It's not that QUBIC the project doesn't have the same level of depth. I think QUBIC the project has as much depth as you'll ever find, but I think the white paper doesn't completely reflect that, and probably the reason is that Sergey Ivancheglo didn't write the white paper. Some of the team did, and this is going to be an evolving document as well, so it may evolve over time and add more stuff in, but you'll see what I mean as we go through. But anyway, the whole point of this is really bullish because the white paper, lots of people have been saying it would never come. It's here now. It does what it's supposed to do. It adds a lot of authenticity to QUBIC. It makes QUBIC seem a lot more legitimate. A lot of people who are on the fence about investing are going to invest in it now and have been investing in QUBIC because of the white paper. And a lot of the people who a tier one listing can now happen because you need a white paper for a tier one listing. So it's a big deal for that reason. So the first thing that happens anyway, when you open the white paper, is you see the abstract, and it just explains some of the issues of blockchain technology. I'm not going to go into reading this because, we've got nearly 80 pages to go through. It's a general overview, pretty straightforward. If you guys follow this channel, you'll know about it. Otherwise, if you don't know about it, QUBIC's idea, what they're going to do with AGART's useful proof of work, what makes QUBIC unique in terms of scalability, things like that, then you're not going to you should look into this. By the way, the topics that are really interesting in this white paper come in the areas of bare metal, working out bare metal and security, and that's what I'm excited to show you as we work through this. So I'll get to that. That's the stuff that surprised me and was really interesting. So again, the abstract, this is just an introduction, really. Then we've got our table of contents, and then we get into the proper white paper. And again, we've got an introduction, which again is just talking about those ideas, the kind of areas that QUBIC's tried to solve, and who created QUBIC, and generally just that they're talking about how proof of work projects have a huge issue because they waste all that computational power. Proof of stake projects have a huge issue because they become more centralized. They generally just don't work. QUBIC's trying to be in the middle, and it is in the middle by the looks of things. It's also then built in a useful proof of work model, so it's not wasting that mining power, and it's very, very scalable. Uses CPUs, and it's got a great creator. Then they go into the problem statement, which again is all about scalability, energy government, energy consumption security, and not being centralized in terms of control. Then it gets into the overview of QUBIC solution, talking about the quorum, and it explains the quorum then, and we get into a bit of detail on the quorum and what it is. Now, this may be covered again, I can't remember, we'll see as we go through the white paper, but the quorum stuff doesn't surprise me because if you've watched this channel, we already understand the quorum and how it's quite decentralized, very secure, and it adds a lot in terms of scalability. We've got like some simple formulas breaking down how the quorum works. But what I did find interesting about the quorum is it's not very clear how decentralized the quorum is. And I'd love the white paper showed, we know Cubic is decentralized, but is it more decentralized than Bitcoin, or is it as decentralized as Bitcoin, or where does it rank in terms of decentralization compared to a lot of other networks out there? Just give me 1 second. I have to let my dog out the door here. Uh, okay, I will not bother editing that out. I think in the video, I'm gonna have to let my dog in and out. Here, I'm working out of the kitchen, so I'm probably gonna have to let him in and out a few times. But anyway, so back to this. So the quorum, I'd love if they explain, because I saw Sergey Ivancheglo about half a year ago, and I can't find it now for the life of me. But he released some information, and he had a numerical breakdown of why Cubic is at least as decentralized as Bitcoin, and he had that in numbers broken down. But that's not in this white paper. So, when I look at this white paper, it sounds like Cubic isn't as decentralized as Bitcoin, but that I just have to go off that now because there's no other information, and I can't find that tweet or Discord post from Ivan Cheglo. But anyway, so that's basically the most important points about the quorum. It might cover that again. I don't think it does though. Then it gets on to useful proof of work. Again, we know what useful proof of work is. It's just taking miners' energy, and instead of wasting it, it actually puts it into something useful, which is training AI. And the funny thing is, that's really all the white paper covers. It doesn't really get into the details of use of proof of work and how it works and how Qubic's managed to code that and stuff. And of course, Qubic's completely open source, so you can go and check the code and see how all this works. But just, if you're a naysayer or you want more details on what use of proof of work is and exactly how it works, it's not there in the white paper. So that's, another slight negative. And then it gets into bare metal and, how that makes Cubic super fast, super scalable, super secure. And this is really, really interesting, the stuff that's covered in this white paper about bare metal. And something that I didn't realize is that it makes Cubic probably the most secure blockchain there is, because most blockchains operate off an operating system, and the more things that you have that are hackable, so for example, an operating system, the more hackable the blockchain is. But Cubic doesn't have an operating system, so you can't hack the operating system. So you actually have to try to find a way to hack into the hardware, but you've no in path into the hardware. So in terms of security, Cubic is probably the most secure crypto project out there, and that's really interesting. And then we know that not working through an OS, an operating system, makes Cubic super fast and super scalable, because you don't have that overhead of system layers, etc. And then it talks about the decentralized economic model, which is all about deflationary mechanisms, incentive alignment, and blah blah blah, which is that's covered in more detail. And then it gets on to AGART. Doesn't really cover AGART in any detail whatsoever. Just says that we're using useful proof of work to train AGART. AGART's its own project, which will have probably its own white paper in the future. And then we got to bear in mind that that's probably going to be covered in scientific papers that are coming up. But really, AGART's just touched on. So again, I feel like that wasn't covered in absolute detail. So then they get onto network foundations. Again, they talk about useful proof of work. But again, I just don't feel like they dug into useful proof of work as much as I would like them to have done. They dig into a lot of how the miners get paid, which is interesting, but not really in general how the useful proof of work operates. Okay, I have to let my dog back in now. Uh, okay, sorry guys. That is the joys of having a dog that loves going in and out of the house. But I'm just going to keep rolling because I'm short in time to make this video. But anyway, we've got all the key aspects of useful proof of work, and we understand these. Purposeful computation, incentive alignment, blah blah blah. It's really, really great, the useful proof of work approach of Cubic, but most of us, I think, watching this video understand useful proof of work right now. I would love if they gave us more depth on that, so that, people outside of Cubic that are really industry leads could understand how Cubic is achieving this. Then we get into the economics, and they're just talking about the mission structures, the deflationary mechanisms that are there, the halvings that are coming up, the mission supply on a weekly basis. again, really simple stuff. Probably very interesting for people who don't understand this stuff, but for me, and I'm sure most of you guys listening, we already know this stuff, how the rewards are spread out, how miners get paid, and how much is released every week, and we just know that this is hitting a deflationary model. Then it touches on the consensus framework, obviously, which makes QUBIC very scalable. Again, it doesn't go into a lot of detail there. And then it gets into the quorum consensus algorithm. And this is interesting. Definitely it gets into how more details and how the quorum works here. I just would love to hear about how decentralized the quorum is. There's some equations in here, but again, they're really, really simple. And you guys probably understand this already, but the quorum makes QUBIC super secure because you have to control 66% of all QUBIC's computer spots, or all of the quorum, to take over power the QUBIC network. Generally, with most other blockchains, it's 51%. So again, it just seems to me that QUBIC is the most secure blockchain that's out there. Then they just get on to the voting, which is interesting. They get into the vitalization consensus, which again is interesting. And this is just about how QUBIC arrives in consensus for agreeing on transactions that enter into a tick. Quite simple stuff again when you're into the project as much as I am anyway, and how QUBIC is very, very decentralized in what it does. But again, is it more decentralized than Bitcoin or CAS or anything like that? We don't know. So yeah, that's a bit disappointing. Then we get into the Byzantine fault tolerance. Again, just talking about how it's very hard to act maliciously on the QUBIC network, which is really good. The fault tolerance thresholds, you need to control 66% of the QUBIC network. Basically, so all stuff that I think we all should know. And then there's things about roles in the network. So computers are the quorum members. So we understand all that, and it just goes into what a computer is. Miners, we understand what they are. It goes into more details in the miners, but all straightforward stuff. And then the arbitrator, it explains what the arbitrator is and how they have power over the quorum, can remove quorum members, can publish quorum lists, but also that the quorum can vote out the arbitrator if they think the arbitrator is malicious. So it just shows how that's a decentralized area. Then it moves on to system architecture. So in the system architecture section, it just gets into the bare metal deployment part, which is really, really interesting. So again, just basically the bare metal makes QUBIC really fast. Just like I said at the start of this video, it makes it really fast and really secure. Fast because it doesn't need an operating system, doesn't have that lag. Secure because it's almost it's really hard to hack because you don't have an operating system that you can hack first to get into the system. You actually have to hack into the hardware itself, which is great. And it uses UFI, can't remember what that stands for now, but it's programming directly onto the hardware, which is a really unique skill. And that's, as far as I know, QUBIC is the only crypto project that uses UFI and the only one that uses bare metal deployment, which would lead you to believe, and I think you'd be right in saying, I can't prove this, but I think QUBIC will see the proof of this coming in the future, but QUBIC would be the fastest crypto project out there, the most scalable crypto project out there, and the most secure crypto project out there, just because of that bare metal deployment, because no other blockchain does that as far as I know. And this is an interesting way of putting it, is that the security element of QUBIC is based on the fact that they removing that operating system removes the potential attack surfaces for someone to attack when they're trying to hack into the network. And then the supporting research and citations they have in here about what do we have that's interesting? So known communication. I mean, a lot of this stuff is getting a bit more into depth from a programming point of view. Wasn't really super interesting for me. I didn't think it added I think it just explained how QUBIC was super fast and super scalable, but I think this was something that I could breeze over. I didn't quite understand the peer sharing. I didn't think it was of huge interest to me, but again, it was explaining how QUBIC is decentralized, which was interesting. And then we get into smart contract execution, which again, we generally all know about QUBIC smart contracts. And it's basically just a case of that, again, through using C++, and bare metal deployment, QUBIC smart contracts are super secure and super decentralized. That I know I'm breezing over this stuff, but it's it's all the same stuff. It's really important and really interesting, but I just don't want to dig into it in too much depth as we're going through it here, or this could be a 3-hour video otherwise. And then we look in the ecosystem and they talk about product development, and there's the development teams that are working here and the community initiatives. So they're talking about Votan, who is or Votan, who's building bridges towards the Ethereum and Arbitrum network, and is going to build bridges to all networks. And then they're talking about the grants program here and the incubation program. So the grants program provides grants for not-for-profit ventures on the QUBIC network, and the incubation program provides grants for-profit ideas that people bring to the QUBIC network. And then it covers use cases, and it talks all about the use cases. So we've got decentralized computing power, which is just like the useful proof of work model, smart contracts, micropayments, AI training and validation, decentralized exchanges, and there's so much more stuff they could have talked about in use cases there, but they haven't touched on, and hopefully they'll add that stuff in future. And then they go into the consensus mechanism, again talking about what Byzantine fault tolerance is, just in a bit more detail. But it's really straightforward. I don't want to say straightforward stuff, but it's quite simple to understand when you see it. And then what the quorum is, quorum-based consensus algorithm. I just think we can fly over this. It's just about how QUBIC remains decentralized, and how it remains secure, and how you need 66% control over the network to control QUBIC. And it just digs down into more details about tick leaders, epochs, tick data, the arbitrator, just stuff like that. But it's very, very straightforward. Just some of the mathematical approaches for deciding who the tick leader is at a time. But yeah, I just feel like I'm digging too much into things to go into that any further. And then it just talks about how transactions are sent and propagated across the network. Nothing hugely interesting for us as investors in QUBIC. And then if things about manual intervention for operators as well. And then it gets into security analysis and the mechanism's resistance to various attack vectors and how it ensures network integrity. And this is pretty cool. So it's resistance to Byzantine faults it talks about, and then cryptographic security. And basically it's just again it's showing that QUBIC is super secure here, which is really interesting, and how the arbitrator can remove malicious individuals from the quorum, and then the quorum can override the arbitrator as well. So really straightforward, but really interesting stuff. And then we go into economic models, and again we get into the emission schedule. So yeah, in the economics section, again we're talking about emission schedule, stuff that just is really, really simple to understand, and most of you guys should understand this. And then about the mission phases, and just this again is talking about how the halving will happen, the burn rates. Really interesting stuff is about the supply watcher. Something that I think is very unique to QUBIC is that there's an AI element that's going to watch the supply and make sure that the supply is never inflating too much or deflating too much. That's a really, really cool area of QUBIC. The fact is, when you understand QUBIC's tokenomics, it's some of the best tokenomics in existence. It looks scary on the surface, but the QUBIC's got incredible tokenomics. And then it moves on to the sustainability phase. But the most interesting thing is the supply watcher. That's really interesting in this element. And then we've got some charts breaking down the mission schedule, comparing it to the Bitcoin schedule, the formulas for the halvings, the reward distribution, loads of stuff, but it's really, really straightforward stuff. So I'm just going to breeze through it. And a lot of stuff like coin burning that's really interesting as well. And the incentives to miners, to computers, to keep them interested, incentives to coin holders. I mean, it looks like I'm flying through this stuff, guys, but so straightforward that you as a QUBIC user should know this. If you don't, I recommend going in, taking a bit more of a look, but it's really just about the whole point of the deflationary mechanisms and the halvings that are coming up. The security section is really interesting because QUBIC is so secure, and that's amazing. Like, it's probably the most secure crypto around and the most secure blockchain that exists. I don't know that for a fact, and I'm not some super developer or anything like that can tell you that for certain, but from what I understand, there's probably not going to be many more secure projects than QUBIC is. It uses a Kangaroo 12 algorithm for hashing operations, which apparently just makes it really, really scalable, which is great. That's, again, why QUBIC's so focused on scalability and speed. So it discusses that. It uses for digital signatures, the 4Q system. Getting a bit over my head, this, I don't understand that in detail, but apparently it's good. But then we talk about key management, and how that's important, I guess. But I don't understand that in detail. But here's what I do understand in detail: is the attack vectors and the mitigations. Really cool to see that QUBIC is so resistant against Sybil attacks, where people can't spam the network, because they must use proper signing methods, and the use of proof of work model makes it a lot of computational power is basically needed to perform a Sybil attack. So QUBIC is really, really resistant against Sybil attacks. It's really resistant against forking attacks as well because of strong finality. So once the tick is accepted by the quorum, it is considered final, and subsequent ticks build upon it, and that finality is almost instantaneous. And then, honest computers follow the chain with the highest cumulative score. So it's really resistant to forking attacks, really resistant to collusion attacks because of randomized quorum selection. So it's unpredictable. And then there's the fault tolerance threshold, where you'd need to control 66% of the network. Anyway, I actually do, though, think it's one area that I'd love to know a bit more about in terms of collusion, because I do wonder, well, isn't it possible that all members of the quorum could collude together? And I know that they say what prevents that is randomized quorum selection, but I'd love to see more of a display of this. So that's interesting. Replay attacks, so where people resend valid transactions to disrupt the network, but QUBIC has this duplication ignore built in. And then 51% attacks are obviously impossible because it needs to be a 66% attack with QUBIC, which is really, really difficult to do because of the cost actually of acquiring those resources. So QUBIC's super secure from all those things. Eclipse attacks, where an attacker isolates a node and tries to give someone a fake view of what's going on in the network. And apparently that is quite difficult because of the diverse peer selection and connection limits, and then the separation of in and outgoing connections. So apparently, I don't understand this part in detail, but apparently it's very resistant to Eclipse attacks. And then smart contract vulnerabilities. Well, the main thing that I understand is the auditing of the code that smart contracts are written in makes them really, really hard to hack. And then I presume the operating of raw metal as well makes it difficult. And then there's restricted language features as well. And then quantum computing threats. So QUBIC isn't quantum resistant right now, but what's great to know is that there is there's research and development going on around this, and then the QUBIC algorithm is agile, so it can be adjusted to become quantum resistant when R&D figures out how to do that. So yeah, that's all really interesting. And then obviously malware and node compromise, and so much that's got to do with preventing that's got so much to do with obviously updates and patching. But the fact that QUBIC runs in bare metal, so you can't put malware onto the operating system because it doesn't need the operating system, and that's a really important thing. And then we go on to the conclusion, and the conclusion is QUBIC's conclusion. But as you can see, I've flown through there, guys, because there isn't that much. If you should know all this stuff if you follow my channel. And I wanted to share with you guys who know about QUBIC, have followed my channel, but haven't had time to read the white paper, to see that you're not missing the world of stuff in the white paper. It's just really great to have it for that tier 1 listing, really great to have it for the authenticity it brings to the QUBIC network. It's obviously helped pump the price of QUBIC a lot because people have a lot more belief in QUBIC. There's going to be a lot more stuff coming down the line very soon that's going to pump the price of QUBIC a lot more. So I wouldn't even worry so much about the white paper. And I think that's really, there's, I'd love to cover it in a lot more detail, but I think that's really all I need to say on the white paper. But if you guys think I've missed anything important, please drop it in the comments, and we can discuss it there and educate the community at the same time. And that's all I've got for you guys. I'll see you all on the outside.